measuring. It's kind of hard. This thing is attached to me. Let me unhook it. Measure my litter and duff. So right there, I know it's hard for you to see, but I'm right at 2 inches for my litter. So this is at 40 feet. And I'll show you this data sheet at the very end. Kind of what it looks like up close. 2 inches. Duff. So remember, duff, we're looking for a duff is basically getting past that organic material down to the mineral soil. So I'm just going to dig with my go no go, and I don't have very far to go. I'm already in the mineral soil. So that's kind of where I'm digging. So I'm just measuring that space from the organic layer to the mineral soil, and it is, you know, it was basically a 1/4 inch. So that's what I'm going to put on the data sheet. Let's see here. Let's move over here so I can show you kind of what I'm doing. Apologize, this is pretty rocky, but so 0.25 as my duff measurement. So here's what I've done so far. I'm gonna go ahead and close that one out. So I tallied my ones, tens, and hundreds. I had 0, I had 1 hour, 1 10-hour, and 0 100 hours. I had 1,000 hour, that was 3.5 inches diameter. It was a hardwood and a decay class of 4. So working backwards, I've done working on my litter and duff measurements. So litter was 2 inches, duff was a 1/4 inch, and my down and dead woody was 0. So I'll do the same thing at 12. Let me grab my go no go. Come back to 12 feet. Gotta find it. There's 24 feet. So I need to back up. Actually, we need to do it 25 feet. So we'll just do it back here. So again, I'm measuring litter. Litter's about 2.5 right here. So I'm gonna put that in. 2.5 inches. And then let me tuck this camera back in here. I'm looking for duff. And again, that's about a 1/4 inch of duff down to the mineral soil. So I will put, there's no down and dead woody fuel here. So that height goes to 0. And then I go to 12 feet and I do the same thing. So I'm here at, let's see where I'm at 10 feet. So here's 12. So again, litter, 1 3/4 inches, duff, 1/4 inch, and then 0 for my down and dead woody height. All right, I'm gonna go over to my truck here, right on my tailgate, so it'd be a little bit cleaner for y'all. Okay. So duff, 0.25. I believe I said the litter is 1.75. Might be mistaken. And then that's a 0. So this transect is done. So, and normally you have 3 transects. Okay, and you can orient those transects any way you want, but a very common orientation is something like this. And actually, let me change the arrows on this one, basically because the direction you travel alternates. So the first transect, you'll go out from your origin. The second transect, you'll come back in towards your origin. And the third transect, you'll go back out again. So 0 feet starts at different places for one of the middle transect. You can also have, you know, transects that go out something like this. you know, kind of spread them out like that. One reason you're going to orient your transects differently is, let's just say we had a log right here. Okay, that's my log. So if it was right here near the origin point, it would get counted 3 times. You know, and we started, let's just assume that we started here. Actually, let me back that up. Let's just say it was 100 hour, okay? So it would get counted 3 times, okay, because we counted on each transect, whereas here it's only counted twice on these 2 transects. So it just helps to reduce the double tallying of fuels, okay? So that's Brown's transects, also called the planar intercept model. So that's pretty much it in a nutshell. You would do that across an area, across your stand. There's a complex formula that has already been worked up, and all you got to do is plug in your values for your different fuel measurements. Okay, so another way that we quantify fuels is basically just destructive sampling. So what we would do here, the easiest way to do it is, you know, similar to a timber cruise, we only sample a small area, and then we use an expansion factor to blow that up to a per acre basis. So what I've got here is, this is a PVC square, and so this square is a 1/4 meter in size. So I would tally everything in this square, put them in different size classes, you know, 1 hour, 10 hour, 100 hour, and do plots like this all across the stand, and then expand it out to a per acre basis or a per hectare basis. You know, since I'm using meters here, we want to maintain those metric units, and metric units are just a whole lot easier to work with. So again, all I would do is, you could either tally everything or collect it and take it back to a lab or wherever you're working and weigh it. So again, just to kind of show what this no-go looks like. So that's too big for the 1 hour, but it fits in the 10 hour, so that'd be a 10 hour. Let's see if I can find a 1 hour. So this will probably be a 1 hour. Oh, nope. Still too big for a 1 hour. This will be a 1 hour. So here we go, 1 hour. Fits in there in the 1 hour slot. So that's, you know, basically how you do that method. You just take, you measure or gather every stick you see in this square meter, and, you know, assign it a class. You would put it in bags. What I've done in the past is to get 4 or 5 bags, label them 1 hour, 10 hour, 100 hour. Now 1,000 hour, obviously it's doesn't make a lot of logistical sense to try to haul out 1,000 hour fuel. So we would just, you know, we wouldn't measure 1,000 hour fuels this way. But your 1 hour, your 10 hour, your 100 hour, you bag them up in paper bags with labels on them, take them back to the lab, and you weigh them, and you get a mass. And you want to let them dry out. You want a dry mass. So typically you can put them, you can either air dry them, or you can put them in, you know, a special room. I can't remember what it's called. You know, it's basically called an air dryer, just called a dryer. It's just a room. You know, a lot of universities have them where you walk in and you can set your samples in there, and it's at a very dry, you know, almost zero humidity environment. Let them sit there for 3 days or so, and that'll take all the moisture out of it. And then you weigh each sample to get a dry mass of your 1 hour, 10 hour, 100 hour fuels. So the third way that we can look at fuels is, I don't have one with me, but we have a fuel photo guide, or actually it's kind of 2 different ways of the same way. So we have a photo guide, which is just a situation where people have gone out to areas, they collect the fuel mass, and then they give you, you know, parameters like this, you know, X elevation, X aspect, and X amount of basal area and species composition. And they do that for a wide variety of sites. So, you know, your south aspects, your east aspects, your southwest, you know, all your aspects that cover all your elevation ranges, that cover all your community types, a range of basal area, and a range of understory composition, things like that. So that's called a photo guide. So the idea with that is you walk out into a stand, you flip through it based on your elevation, your aspect, and your cover type, and you can kind of estimate, okay, what the fuel loading is based on that photo guide. Another thing is called a fuel photo series. So it sounds similar, and it is very similar, but it's just kind of pictures of different loads of fuels. So it'll probably be, you know, some instances it's anywhere from 8 to 15 pictures, and each picture just has an increasing amount of fuel in it. And so with that, there's a fuel amount or a fuel loading. Sorry, there's definitely a deer or something back there. Just run off. Oh, nope. Yep, there it goes. So the idea with that fuel photo load series is, you know, you have each successive picture has more fuel in it, and so you just pick which picture is closest to what you see on the ground, and that gives you a tons per acre or tons per hectare, whatever units you're working in. So we have the Brown's transect, which you just follow the transect and you're tallying fuels that intersect the transect.